हेलो, आवाज क्लियर है? प्लीज कंफर्म द साउंड. जस्ट कंफर्म द साउंड. ऑडियो वीडियो सब कुछ क्लियर है? जस्ट कंफर्म द साउंड. ऑडियो वीडियो सब कुछ क्लियर है? Good evening friends, welcome to Global Gate Academy. So this is Satish Kumar Drishetti, faculty of IIoT and Instrumentation. So I hope all of you are fine. In the last series we have started the instrumentation concepts, advanced concepts which are more profoundly asked in the industries and which are ruling today's industry. So those topics are also I am giving as a awareness. Okay, especially the industrial revolution 4.0 has happened. Many of the things are converting into digitization. Even the instrumentation concepts are also converted into the digitization. So keeping this in mind, I am forwarding you a new topic today, that is the IIoT. So the topic name here today is IIoT. IIoT stands for Industrial Internet of Things. Okay, Industrial Internet of Things. So in the last lectures I have given you the basic idea of Internet of Things, and today's lecture I am going to give what is the Industrial IoT. Okay, so try to understand what is IoT and what is IIoT. So today's class, the agenda, what I'm going to discuss, just the basic introduction of IIoT and what do you mean by IIoT and IIoT architecture. So these are the major things that I want to going to discuss. Whoever watching the session, once try to confirm from your side. Yeah. So what is IIoT? What is the difference between IoT and IIoT? So before understanding IIoT, let me talk about what is IoT. So how to describe the IoT, my dear? So how the IoT can be described? IoT can be called as Internet of Things. So first of all, you have to understand what is these things. Things means what? Things means many things. It can be sensors, it can be devices, it can be animals, it can be biological things, it can be our home, it can be electronic, which is having some embedded concept, embedded processor in it. So let us see what is IoT definition. It is described as the physical devices. What are the physical devices? Like mobiles, personal computers, home appliances, and many more electronic devices that are embedded with the sensors. Embedded with the sensors, softwares and other technologies to transmit and share the data and communicate the data among themselves through the internet. So many devices, when I say the things can be sensors, the things can be the personal computers, the things can be the home appliances, the things can be the softwares, the things can be the technologies, the things can be the biological things, the things can be the animals also, which can share and which can publish, which can communicate themselves among themselves, which can share and which can communicate among themselves by using some internet. Okay, that's why it is called as Internet of Things. So what are the things means here? The things stands for, what is the things? Things can be the things can be air conditioners, sensors, smartwatches, mobile phones, etc., etc. Even the biological things also we can keep. So, this is IoT, my dear. Then what about the IIoT? Industrial Internet of Things. So, how to understand this IIoT, Industrial Internet of Things? So, when you apply the IoT concept to the industry level, then that is called as IIoT. It is with respect to instrumentation point of view, it is more important. Instead of devices, we are going to connect the major networks here. It is described as using the Internet of Things in industrial applications and sectors. The IIoT refers to interconnected sensors and other network devices together with computers, industrial, mainly used in manufacturing. If we apply the IoT to the industry, then it is called the IIoT. For example, the Amazon warehouse, the smart robotics, Airbus. So, these all are the examples for the industrial Internet of Things, my dear. Okay. That means what? When you are applying the Internet of Things subject to the industrial applications. Okay. One second. So, industrial Internet of Things, it is described as using the Internet of Things in industrial applications and the sectors. The IoT refers to interconnected sensors and other network devices together with computers, industrial, mainly used in manufacturing. Okay. So, when you are applying the IoT subject to the industrial applications, then it is called the IIoT. So, next, if you see this picture, the IIoT is a subset of the IoT. In the entire IoT, the IIoT is a subset. Okay. Of course, earlier we are having industry, so I think it is not visible to you. So, let me draw the diagram. So, here if you take this entire thing as IoT, if you take this entire thing as IoT, so in that there are two subsets. One is the industrial 4.0 and next comes the IIoT. So, IIoT is the subset of the IoT. That is the point you have to understand. Okay. So, today in the world, many of the devices are connected to the internet, starting from the mobile phone, home appliances, your water level, your air conditioner, okay, your total home appliances, even the farmlands, even the hospital patient monitoring systems, transportation, everything, what not, many things are today connected to the internet. So, if you see today in industry, the 4.0 strategy is running. So, what is the industry 4.0, my dear? Industry 4.0, before, first it was industry 1.0, it was started in 1784, then industry 2.0, industry 3.0, industry 4.0. Okay. I think it is not clearly visible for you. Yes. Let me some slides are colored. Yes, I think now it is visible. Chalo. So what are the major things in the study of industrial internet? Okay, so let me take the industrial internet. So in industrial internet, what we are going to do? We are going to connect many heterogeneous devices. Many heterogeneous devices are going to be connected and they are going to communicate. They are not homogeneous. Some of them may be following Wi-Fi technology. Some of the devices may be following the Zigbee technology. Some of the devices may be following the Bluetooth technology, but among them they have to communicate. And in normal mode, we used IPv6 for LAN and WAN generally. But when you talk about the technologies, there should be some machine-to-machine communication, SCADA, HMI, industrial data analytics, cyber security system, data acquisition system. So these all are the part of the industrial Internet of Things. In basic Internet of Things, just we are having the sensors and devices connected to the internet and cloud system. But when it comes to the industrial Internet of Things, there are different technologies, different machines, different data acquisition systems have to be interfaced to the internet. And this connection can be, most of all the cases, to be wireless. And when you are using the wireless communication, you have to follow the different protocols. See here. So when you are connecting these particular things, you have to follow the low power supply based wireless networking technologies. So here comes the extension of the knowledge for the instrumentation student to the computer networks. Up to now, being instrumentation students, you may be studying the sensors, actuators and all those things. But now onwards, you should be focusing some more knowledge on the computer networks. If we divide the total industrial Internet of Things into some layers, first you are accessing the data from the devices. So there may be some certain protocols. After accessing the data from the sensors, you have to publish through the network. So there is a network layer, and from the network layer it will go to the data storage. Then from the data storage it will go to the application layer. At every stage there are certain number of hardware devices. At the same time, at every stage there are number of certain softwares and protocols. Everything you have to understand. Okay, so just as a glimpse I am giving today, industrial and IP enabled low power wireless networking technologies needs low power wireless solutions. So what they require? They require low power wireless sensors. Power consumption requirements should be less. Okay. So if you see some examples I will give you. For example, if you have the PLCs and SCADA, PLC versus SCADA. So when you are mixing the PLC versus SCADA, what happens now? PLC plus SCADA relationship, you have to know as, when you mix it with PLC and SCADA, if you see the PLC is a hardware, right? This is a hardware, and SCADA is a supervisory software. Okay, so when you mix the PLC and SCADA in an industrial network, that means what? Now it has becoming like an operational technology, what we call it as OT. When the PLC and SCADA added together and combined to the industrial network, then it is called as operational technology. Okay, so it is different from the IT technology. Okay, in IT technology, what we'll use? What happened? Yeah, there is a small technical glitch. Okay. So in IT systems and operation technology systems, what's happening? See, when you are mixing the PLCs and SCADA, and when you are keeping PLCs and SCADA, when you are keeping an industrial network, there are mainly 4 requirements: the cost of the continuous operation, the safety, the real time operation. So, when you are integrating certain systems, there is a lot of problems of security. Just like in traditional IT systems, when you are integrating 2 different platforms, there is a possibility of some cyber issues. Here also, when you have different levels of hardware, when you are interfacing in IIoT, we should follow certain protocols. So, as on today, how many devices connected? Almost this many devices are connected in IIoT. Hardware point of view, in industrially, coming to different types of sensors: temperature sensor, humidity sensor, flow sensors, home appliances, biological specimens. How many devices connected as on today? This many devices, and still the count is growing. Okay. So, if you see, this is the fundamental thing you have to understand. Generally, when you want to understand the architectural view of IIoT, Internet, Industrial Internet of Things, this Industrial Internet of Things majorly divided into 4 layers. Okay. I am telling that applying the IoT to the industry 4.0, 1.0, 2.0, 3.0, 4.0, these are the technologies of the industry. 1.0 is first started in the 1700, where the machines just started, steam engines started, that was 1.0. Next is 2.0, slowly the people are entering into electronic side. Okay. Once it come to industry 3.0, it went into automation. Now it's industry 4.0, it is going to digitization, internet. Okay. That is advanced level of industry. This is a industry 4.0 revolution. So now the IIoT reference model architecture can be divided into 4 layers. One is the first one, which deals with the devices through which the sensors information is coming, that is under this device layer. And the next one comes the network layer, and the next one is the service support and application support layer, and the last one is application layer. As a collaboration, security and managements are also present. See, architecture we have divided into some layers. Architecture we have divided into some layers. At each and every layer, some set of hardware devices will come, some set of protocols will come. Okay. So, please make a note of this point. The industrial Internet of Things reference model has having the 4 layers. One is the device layer, network layer, application support layer, and last one is the application layer. It is easy to understand the architecture when you go like this. Okay. Because what we are going to do now, we are going to merge the different subjects. When you are going to merge the different subjects, then there is a possibility of superposition. That is why where the sensors and actuators and gateways, all those will come, that will be under the device layer. It just like you can compare with the computer science OSI ISO layers. Just like in our computer networks, OSI ISO layers, first you are having the physical layer. In physical layer, where we will be talking about how the 2 systems are connected by using the cables, coaxial cable, okay, fiber optic cable, that is a physical layer. Next comes the data link layer, next comes the network layer, next comes the transport layer, next comes the session layer, next comes the presentation layer, next comes the application layer. Okay. So, that is a reference you have to understand. In OSI model, so we are having these layers. So, first comes the physical layer, next comes the data link layer, physical layer, data link layer, next. So, this is what we call as physical layer, this is the data link layer, next comes the network layer, next comes the transport layer, next comes the session layer, after the session layer will be the presentation layer. After the presentation layer, we got the application layer. Application layer. So this is generally the OSI ISO model. Okay. It is the OSI ISI model. Okay. But when it comes to the IIoT layers, this is the OSI ISO model. In computer science, we will study this OSI ISO model. But now, here what happened? The first two is categorized as directly device layer. This is a way you have to compare. Okay. In OSI ISO model, that will deal with how two computers or how multiple computers can be connected and how the data can be exchanged between the computers. That is dealt with OSI layers, open system interconnected, that is given by the international standard of organization. Then it is just, if you compare with IIoT, these first two layers, physical layer and data link layer, that is merged as one device layer, and network layer is as it is, my dear. This network layer is as it is. Next, the three layers, service support and application support layer, this transportation layer, all these together, these three together. Okay. So these three together now has formed as what layer? Service support and application support layer. Service support and application support layer. And the last one, the application layer is as it is. Application layer is as it is. That means this is the IIoT layers, or we can call it the architecture. These are 7, these are 4. Okay, 4 layer IIoT architecture. So you should correlate this computer network subject with our IIoT subject. That's what the interesting story of this particular subject. We are going to merge the instrumentation devices. So what will come under the devices? Under the devices we will get sensors, you will get actuators, you will get some gateways, hardware, all the things will come under the device layer. So that's the point. Yeah. Now let us go some elaborated way. Now if you see the device layer, just I have elaborated. In the device layer, what are present? In the device layer includes what actually? Device layer includes the particular device capabilities and the particular gateway capabilities. Why? Because from this particular device, whatever the temperature you are taking by using thermocouple or by using RTD or by using LM35 sensor, this particular data has to be driven to the next level by the gateway. We are sending this data in the form of digital bits to the gateway. So each and every device capabilities and gateway capability that will come under this device layer. And the network layer includes the networking capabilities and transport capabilities. Service and application, it is general support layer. And finally, the application layer, IoT application, this is important. IoT application means it can be a health monitoring system. Finally, you are applying the concept of this information of sensors, networking, to a health monitoring system, or to a paddy, milk processing stations, or to agricultural station, or to a water storage or water pollution monitoring system, or air pollution monitoring system, traffic monitoring system, home appliances, like this application can be any sector. Okay. And this particular information again we can share between the companies, between the business applications. That is why these all management capabilities and security capabilities all will come on the right side. Okay. So, this is the way. Actually speaking, there is no standard architecture, my dear. It is emerging technologies already. Every year some research is going on in this particular IoT. Every year some new things are coming. That is why a set of architecture, just like if we say 8086 microprocessor architecture, we are having the standard architecture. PLC architecture, there is a standard architecture. But when it comes to IoT or when it comes to IIoT, as we are going the technology, the architecture goes on modifying. Okay. Chalo, first we will talk about the device layer. What is the first ground layer? The ground layer is the device layer. So, in the device layer what will come? In the device layer what are the things we are going to get, my dear? Okay. In the device layer what are the things we are going to get? It is going to deal about the devices which are going to collect the information from the field, from the physical atmosphere. Devices that transmit and receive the information over the communication network directly without using any gateway. Sometimes devices, they may not require any gateway, directly wireless they can send. Okay. Next, some of the devices, they through gateways, some of the devices compulsory require a gateway because the device may have the bunch of the data. Okay, na? Bunch of the data. So, then there is a processing is required. So, we are using a gateway. The gateway is called edge also. Okay. So, these devices communicate directly without the use of communication network, but being able to communicate over local networks or to form the HOC, ad hoc networks. Okay. Sometimes they may not use gateways, but they are able to connect themselves. A thermocouple can connect to another flow device. A flow device can connect to some other hot device. So, different technologies are there na, hot protocol. By using that they can be connected. Okay. And remember, whenever you are accessing the data from the thermocouple, I do not want the data from the flow device. So, flow device has to be turned off automatically when thermal device is working, or thermal device has to be automatically off when flow device is working. That type of mechanism should be developed between the devices. So, this is what we call as intercommunication facility, so that the power consumption is going to be reduced. That is one of the important feature of the IIoT. Whenever you are, suppose if a officer is there, officer is sitting in the AC room, okay, he is a officer, and by the evening 4 o'clock he will leave. Sometimes what happens, the people may forget the turning off the AC. So, there should be some IoT mechanism such a way when the person leaves from the cabin, automatically the lights and the fans and the air conditioner should be off, and that should be published on a global application called a mobile application. Right now at 4:30 this person has left the office, his appliances are automatically turned off, so that the power consumption is going to be reduced. So, this facility comes through what? This facility comes through the devices ability to communicate among themselves. Certain devices definitely they require gateway, certain devices may not require gateway, okay, but there should be a position to communicate among themselves. Next, and whenever the device layer is using the devices, how these devices will communicate them among themselves? How these devices will communicate among themselves? They will use some wired and wireless communication protocols. They may use certain Bluetooth. See, this is a wireless communication, Bluetooth and Zigbee, okay, and CAN bus, Wi-Fi. So, these are the things especially instrumentation student must know when it was what is the range and what are the things, okay, and they may need certain protocols also. Different devices will follow different protocols. So, first particular device protocol may not be understood by the second device. So, this protocol conversion also has to be done, okay, protocol conversion. This is what we call as interoperability. Okay, na? So all these things will come under the device layer. The device layer takes care of the devices communication. If the devices are having individual protocols, the device layer will take care of converting this particular protocol so that other device also can access. This is what we call as interoperability. The interoperability is provided by the device layer. Chalo. Now, if you see what are the many different devices that can be used as the gateways. We can use the ARM, just like our LPC2148 microcontroller kit, Arduino, AMD, Qualcomm, NVIDIA, electric important, microchip, Intel. So these are the different gateways we can use. Ante collecting the data from the sensors and sending to via a gateway. In the place of a gateway, we can use all these things. So this is a symbol of our edge, our gate. Okay, instrumentation students, try to understand our journey is slowly enhanced, expanded from the sensors level to the advanced level, embedded level. Chalo. Next comes the network layer. Remember my dear, we do not have the transportation layer, we do not have the other layers, directly we are going to the network layer. In the network layer, what happens? These all devices have to be connected in a group, right? Okay. So whenever these devices are connected in a group, there should be a protocol conversion. There should be a protocol conversion. So in the network, there should be a traffic control also. Multiple devices have to be switched on, off automatically. The routing should be happening. So all the network related issues will come under the network layer. So it includes user traffic transport as well as the transport of control and management information for IIoT service and applications. What it majorly includes? Traffic transport. It will take care of the traffic transport in the network. Okay. So next, see, if you see the network layer contains the many technologies, many protocols. See, what are the protocols here? It is using the Wi-Fi, constrained application protocol, Z-Wave, Z-Wave we call, MQTT, message queuing, telemetry, transmit. Next, DDS, AMQP, advanced message queuing protocol, XMPP, extended message protocol, Bluetooth, different devices. Okay, na? Too many hubs will be there here. Okay, na? There may be different devices of hubs may be there here. Different devices of hubs. Okay. So different devices, they have to be interfaced by using some protocols. So these are the different protocols. So this is what we come under the network layer. Network layer talks majorly about the protocols. Device layer also is having certain protocols, but these protocols are about the exchange of the data over the internet. Okay, na? Between the devices over the internet. Okay, my dear. Last comes the application layer, higher layer of the IIoT. Okay, na? After, of course, the support layer is there, and after the support layer, the final layer is this one. So this is application higher layer, which is including the applications of the smart devices. That can be a mobile, that can be a health monitoring system, that can be a traffic control system. Okay, na? So that is the application layer. So fundamentally, you should understand what is the difference between the IIoT and IoT. So this concept must be clear, because instrumentation student must distinguish what is the basic difference between IoT and IIoT. IoT is what? It is described as the physical devices. Just for your reference, I have kept all the data. Physical devices like mobiles, personal computers, home appliances, and many more electronic devices that are embedded with the sensors, softwares and other technologies to transmit the data. It is all about the sensors and all over this. But when you extend the Internet of Things to the industrial application, that is called IIoT. That's what in the first slide I have told you. When you extend the IoT to the industry, that is called as IIoT. So what are the examples? Our sensors, our smart machines, mobile phones, air conditioners, these all are the IoT devices. Next, Amazon warehouse, smart robotics and Airbus, these will come under the Internet of the Industrial Internet of Things. IoT deals with a small scale network like LAN, just local area, small scale network. But IIoT deals with a large scale of networks, industry, in the entire industry of sugarcane industry, PLC manufacturing, cars manufacturing industry. So it is a large scale. Okay, na? It offers easy off-site programming, whereas it offers remote on-site programming. Okay, na? So off-site programming, beyond the site you can do it, but here remote programming also you can do remotely. Whatever the device you are having, actuators are at the remote location. Okay, the gateway, the control gates are at the controllers are at the remote location. We cannot enter into the turbine zone. Okay, next. This one, IoT requires identity and privacy. To protect the data, it requires robust security. Of course, almost same. It also requires privacy, it also requires security. It's a short life cycle, but it is a long life cycle, less reliable because there is a possibility of cyber attacks. But whereas it is divided with the PLCs and DCS systems, somewhat we can scalable the security levels. Okay, please make a idea of this. So it is an emerging technology, my dear. So I have followed these following references for the understanding of this data. Because still the research is going on. I will try to collect more information on industry Internet of Things every day. And with respect to instrumentation students, I will come to some advanced terminology. At least you should have some basic terminology. What is IIoT, what is protocol, what is COAP, what is MQTT, what is HTTP, what is XMPP, what is Zigbee, what is Wi-Fi, what is Bluetooth, what is the range, what is the standard, all this information. And what are the layers architecture. Why? Because when you are studying the BTech, you will be taking only one subject into consideration, but when you go to the industry, my dear, these all subjects are going to be integrated. If you say, I am not aware of the operating system, if you say I am not aware of the computer networks, if you say I am not aware of these protocol settings, if you say I am not aware of this cable connection, then you are in the problem. Okay? So this is what the industry Internet of Things we are going to merge. And my dear instrumentation students, try to spend daily half an hour time on certain websites, YouTubes to know what's happening around the world. Because whatever you are studying in sensors and transducers and controllers, the same sensors, transducers, controllers are not used in the industry today. For example, in our BTech we are studying the 8085 microprocessor, but in industry directly we are talking the ARM LPC2148 microcontrollers. In the BTech we are studying the basic PLC, but when it comes to the industry we are discussing the DCS oriented devices. In the BTech we are studying the computer networks, but when it comes to the industry we are studying the IoT networks. So there is a lot of gap is happening and engineering has to be updated every day. Okay, so those students who wants to enter into the industry one way or other way, they have to know the latest technologies. In fact, that will be more trendy towards the present day technology. Okay, so in the coming classes, I would like to share some more topics which are related to the IoT and IIoT. Thank you.